Good afternoon once again. We are back to the afternoon session. I'm very happy to introduce our today's resource person, Dr. Damyanti G. Badagha. Good afternoon, madam. Yeah, we are already familiar with madam's speech in the last session 2 days before. So once again, I'm happy to introduce her to the audience. She did her BA in Civil Engineering from LE College, Morbi, and did her MTech in Structural Engineering from SVNIT Surat. And from the same university, she has completed her doctoral degree in Civil Engineering. And she is having more than 5 years and 3 months experience in teaching. And she has a member in many professional bodies like IEEE, ASCE, ACI, ICACI, ISTE, IEI, ICI, IAAM, ISSE, ISCA, SEF, IGS. So it's a very long history madam is having. Yeah. And she has delivered 8 expert talks in national and international level. And she is an editor and reviewer of many Scopus, Web of Science, and UGC Care journals. Organized many faculty development programs and technical events for both students and faculty members. And she has a big history of awards. I just listed a few things only here. She has received Young Scientist Award by International Association of Advanced Materials in the years 2016 as well as in the year 2017, and Best Young Research National Award from IRDP Group of Journals in the year 2018, and most prominently she was honored by Central Government of India and under the scheme of Beti Bachao Beti Padhao as the most educated girl in the village on the occasion of Republic Day in the year 2018. It's really a great achievement, madam. And she has wrote one textbook and published 6 book chapters, and she has more than 15 journals and 15 conference papers in her account, and has attended more than 37 FDPs and workshops both online and offline. We are very happy to see all your profile and going to listen to you once again, madam. Thank you so much. You can take over the mic. Thank you.
Once again, welcome to one and all. Here I would like to correct one sentence. That experience is more than 8 years. Okay, then and only I am eligible for associate. Right? So my experience is more than 8 years.
Okay, sorry for
yes,
that.
okay, it's okay, ma'am. It's okay because it's a open window, and if you will tell like 5, so many participants will think that ma'am having a experience like 5 and 3 months, and how she's associate, right?
No,
That's
no,
why I'm
no. We
clearing.
are
Okay.
very happy that you are in the young age have completed PhD and have many achievements. It's
Yes,
really
ma'am.
proud to introduce you.
Yes, thank you, ma'am. I'm just take it as a kidding and very light manner, but my
Hmm.
experience is more than 8 years. So now
Thank
we will start our lecture. Thank you, ma'am, for such a nice introduction of mine, and really nice to see you as a speaker by introducing me. And I
you. You're
am
most
again,
welcome.
yes, I am again welcoming all the audience, all the participants, and again thankful to organizer. And we are just within a short, I think within a few minutes, we will start lecture because the PPT is uploading. Okay. Can anyone will respond me? PPT is visible?
Ma'am, not
I
now.
am
Not
available,
yet.
ma'am.
Okay,
Not
okay,
yet.
fine. Yes, please take 1 to 2 minutes because in a last time also it take 1 minute to show on a slide.
Yes, ma'am,
I
your
think
screen is
now you
visible
can
right now,
see.
ma'am.
Now you can see, right?
Yes.
Yes, ma'am.
Now it's okay.
Okay. Yes. So now we will start. Sir, may I start?
Yes, ma'am, you can start. Yes, yes,
Okay,
you can
fine.
start.
Okay. So, welcome to all the participants, organizers, and that academic persons. Today's our topic is ceramic waste management. So, as per my previous lecture style, I'm just taking some pictures. So, from that picture, if my title topic is not clear, like ceramic waste management, but you are attending waste technology FTP, right? So, if we will see with that image, so some basic idea will be there in mind. Some waste type of things are there, and if you will go through the detail in that picture, so this is like a ceramic waste. How you can identify? You can identify the by that tiles. Okay, so tiles, this is a eventually, or we can say this is a naturally come under the ceramic waste, but in detail which type of ceramic waste are available, how we can use, how can we do waste management of this type of waste, these all the things we are going to discuss. But this image only for your clear vision that such type of things are ceramic waste. So now, our first focal point regarding that topic is a type of waste. We are familiar with so many type of waste, fine. But here there is a simple classification like general waste and industrial waste. If we talk about general waste, so there are so many things in our mind that some type of industrial waste or like household waste and like nearby waste which we can see. Okay, but whenever we are talking about industrial waste, so that will be again two types: hazardous industrial waste that may be hazard to environment, like in a waterway or in a airway, means in any means, any natural means, it is harmful to environment. This is a hazardous industrial waste that may be hazardous to livings also. Okay, and non-livings also hazardous industrial waste that will be affect to livings and non-living. So there is again question that, ma'am, we can understand there is a land pollution will be there, water pollution will be there, air pollution will be there. Okay, so environment is affecting because of that industrial hazardous waste. But what about the non-living? So I can say that there is a structure. Okay, there is some structure is there, metallic structure is there, concrete structure is there, some metal is there, means some type of non-living thing which we can use daily. Suppose road, building, any instrument, any metallic things which we can use in a daily life. This is a non-living thing. So that non-living thing also affected due to hazardous industrial waste. Now, general industrial waste, this is not that much hazardous, but yes, we can recycle it, we can reuse it. Okay, so such type of waste, it's a general industrial waste. So here I just written some things for your clear understanding that industrial enterprise generate hazardous industrial waste which contain toxic or dangerous substance in a sufficient concentration or quantity to endanger human being or pollute the environment, whatever what just we discussed. And in general industrial waste, it will not that much hazardous, but yes, we can reuse it, we can recycle it. Okay, so if we will talk about the different waste material with its source and why we focused on our topic, that will be the interesting thing in that. So we will just focus the waste material and its sources. So we know that thermal power station is there, silicon industries, petrochemical industries, automobile industries. Then there are so many waste water treatment plant, then borax production, coastal oyster management area, then municipal solid waste management yard. Okay, not waste management, but waste dumping yard. Then there are iron manufacturing plants, wood industry, demolition waste, thermal power plant, stone cutting industries. These all industries, these all sources are responsible for some waste generation. So which type of waste generation will be there? So from thermal, it will be fly ash. You, if you are able to see my PPT, so whatever I am talking, that you can match with the PPT. Like if thermal power station will be there, so fly ash is there, right? Then silicon industry, so silica fume, this is also one type of waste. petrochemical waste will be there, used engine oil, wastewater sludge, thermal sea waste, oyster shell, municipal solid waste, liquid waste, blast furnace lake, wood chipping, recycled aggregate, shell ash, marble and stone slurry. Then if we'll go with another modified list, then we have industries like stone quarries there, rubber processing industries are there, rice mills, paper industry, sulfur plant, jute and core industries, lime processing plant, ceramic industries, our main discussion topic point, that ceramic industries, glass industries, cement plants, steel slag, mining industry, resin manufacturing, railway engine that yard, not waste. Here I just written waste, but railway engine yard. Okay, so these all are the sources, and we can say these all are the industries from that few type of waste is generated. Okay, so all these waste you are seeing under the label waste material like quarry dust, rubber waste, rice husk, paper waste sludge, hydrogen sulfide, jute and coir fiber, lime waste, and our thin crushed ceramic particles, crushed glass, then cement kiln dust, CO and M2, rich industrial waste, metakaolin waste, thermoplastic waste, cinder and cooker powder. So these are the waste which is because of the sources which is mentioned over here, like from different industries. That's why in my last lecture I told you that if in our curriculum that waste technology type of subject will be there, then we have to put like waste technology part 1, part 2 and part 3. This is the main some pinpoint waste industries, or we can say sources, and based on that waste material. Okay, some pinpoint, there are so many lists regarding the sources and waste material, but we are focusing on some main waste material and main sources, so we can understand that nearby around means surrounding us, whatever industries are, that means from our morning awaken to night sleeping, whatever things we are using, so in each and everything there is a source and there is some type of waste. Okay, that we can reduce, reuse and recycle. Okay, or maybe some waste like PVC. In last lecture one ma'am asked me about the recovery rate of plastic waste, so in that I answered her that when I did it was like 3 to 13. Okay, but now it is recovery rate is a little more. Okay, so day by day there are so many things which we are using and having some sources, and that source is responsible for some type of waste generation. Okay, but here we selected that we make a boundary for one topic like ceramic waste, so we will focus on that. So here, before that waste, we have to just go through the history that why this industry is responsible for that type of waste, and why this is in a picture to discuss over here. So if we'll talk about ceramic tiles industry in India, the size of the Indian tile industry in 2018 was estimated at around 1,145 million square meter compared to 1,080 million square meter in 2017, accounting for 8.7% of the global production, right? So we can just imagine the production of that ceramic tiles. Okay, in India, there are so many places. If I will focus on one specific place, then in Gujarat, there is a Morbi is there, and the Morbi is a big market of that ceramic tiles and everything. And there are so many places where such type of product is going on for production, like ceramic tiles and so many ceramic product. Fine. So we can, from that data, we can understand the huge amount of ceramic tiles production in India. Over the last 2 years, the Indian ceramic tile industry encountered challenges from the economy in addition to the unorganized sector. The ceramic tiles industry in India was estimated at rupees 35,000 to 40,000 crores in 2019. Okay, so we can see the jump of that industry and benefit from that, recording to single digit growth. Nearly around 40% of the industry was organized, while 60% was largely unorganized, comprising players from Morbi, Rajkot, and other clusters. I just told you beginning of that slide that Morbi is the big market of ceramic tile. So from that statistical data, what I just wanted to convey you, the production of ceramic in India, the profit behind that, usage of that ceramic tiles. Okay, India is not only the second largest producer of ceramic tiles in the world, after China, but also the second largest consumer of ceramic tiles in the world after China, with the consumption quantum peak at 750 million square meter and accounting for almost 6% of the world. India is also the fourth largest exporter of ceramic tiles, with the export quantum peak at 274 million square meters compared to 228 million square meter in 2017, accounting for a global share of 10%. The industries mark. Why I am just going through the point, because that points are like a very important point. I don't want to just because of slip of tongue and because of the giving a missing information, I am just reading that lines perfectly. Why? Because this is our base, why that ceramic waste is that much in picture. So the industry is marked by increased spending on infrastructure by government, rapid urbanization, and consumer preference shift, which in turn is promoting the demand for ceramic tiles in residential and commercial building across the country, right? Whatever persons which are coming in my contact, there is a one, maybe you will feel like a funny tagline, but there is a thing. Population is increasing, right? Population is increasing. We having earth only right now. No doubt there are so many planets and we are searching for water, survival and everything. But practically right now, what is in our hand? We in our hand there is earth only. Okay, earth having a specific area, population is increasing, progress, growth, development is increasing. Okay, so by considering all the aspects, that ceramic tiles industry's growth is also increasing. The demands of ceramic material, ceramic product, tiles, everything is increasing nowadays. So this is also good for our economical growth also. And another thing, that in a that much quantity this production is there, so some waste is there. So again there will be a question that how that ceramic industry is responsible for ceramic waste. Many of you little bit aware about that, many of you more aware about that, but we are going to discuss that thing in a stepwise manner, so the people that can connect the ceramic industry's growth, development, and its accountability in a waste generation, and how we will do waste management, and how we will use it in a perfect manner to make it count as an advantageous thing to engineering field. Fine. So key demand driver for tile industries like housing sector, housing shortage, home extension and home improvement needed nowadays, hotel sector, hotel growth, commercial sector, office space, shopping malls. Then we need a good bridge, good transportation system. Fine. So these all are the key demand driver for tiles industries. But the industry is very good for our Indian growth, Indian economy growth. Okay, and we know the key demand drivers. But for that, is there any government initiatives and support? So yes, there is a government initiative and support for that ceramic. Okay, so there is ceramic cluster. We can say that some basic idea is there. You can see the export, technology, and cluster related data. Here, what is the government scheme? Who is the concerned authority? And what are the objectives? If we will understand that chart perfectly, then so many things will be very clear for this topic. So many of you aware about that MSME, okay? Micro and Small Enterprises Cluster Development Program. This is introduced by our government. Who is the concerned authority? So Ministry of Micro, Small and Medium Enterprise is the concerned authority. And if I am not wrong, and if many people is aware about the thing, so MSME Cell is supporting many institute to develop their own business, own startup, and so many things are that. Sastra Buddhe sir is there, and he's a regular basis he's organizing and giving lectures on that. So I suggest people to see that YouTube video on MSME, not particular for this topic, but it will be helpful to many academics like faculties, students for that business. Why I am including that thing over here? Why? Because we are using any waste Okay, any waste, and we are doing something, so we are giving hike to any business, any startup. Okay, that's why I'm including point over here. The objective of that scheme is cluster development for enhancing productivity and competitiveness, as well as capacity building of micro and small enterprise. This is MSE. Now, Industrial Infrastructure Upgradation Scheme, that is IIUS, and concerned authority for that scheme is Department of Industrial Policy and Promotion. This is DIIP. And what is the objective of that concerned authority? They are enhancing the competitiveness of domestic industry by providing quality infrastructure through triple P approach for select cluster with potential to become globally competitive. Then if we'll talk about the technology, then credit linked capital subsidy scheme, CLCSS. So by knowing about the scheme, the what is the scheme, who is the concerned authority, and what is the objective. So why we put this over here? Why? Because under waste technology, we are discussing ceramic waste. If any participant who want to do some collaborative work with any person or your nearby industry, okay, so if you are aware about that scheme, yes, that scheme is available, and some concerned authorities providing fund. This is helping us for some project. So some objective should be clear in our mind regarding that type of waste. How can we use that waste? How can we do business startup things? Okay, that's why I'm discussing over here. So in CLCSS, the concerned authorities, Ministry of Small Scale Industries, this is SSI. And objective is technology upgradation of SSI by providing upfront capital subsidy to SSI unit. Okay. So if objectives are clear, means you have some objective that I want to do that work. Okay. So if you are aware about the authority, so you can directly contact them by email, right? And if you will email them, so you can get the idea that for your objective, this scheme is applicable to fulfill your objective. You can do collaborative work, because if I am not wrong, so there is a mixed audience from different departments, so many people can do collaborative work, because this is the matter of waste. So how mechanical people can connect with the civil, how electrical people will come in picture with the mechanical civil, what is the IT computer people can do collaboration with the mechanical civil electrical people. Okay, so if some objectives is clear in your mind, so you can ask concerned authority your perfect example that some things in your mind and you want to do in a such a way, and for that you need some financial support, help, guidance. Likewise, you can contact them. Then, if we'll talk about the marketing development assistance scheme, then we know that marketing development assistance scheme, this is a MDA, and market access initiative scheme, this is a MAI. This is a Ministry of Commerce and Industry is a concerned authority, and what they will do, financial assistance and promotion of activities for exports, such as participation in a trade fair event, etc. Because nowadays our prime minister is introducing so many schemes, so many fairs. So this is also a good, we can say, good scheme for academician also. They can collaborate with industry person, and they can bridge the gap between industry and academia through some collaborative work. Okay. Then promote export on sustained basis through market studies and survey. This is the, again, come under exports, and the concerned authority can guide us, can help us. Fine. So this is the government initiatives for that ceramic cluster. Now, what is the technology development and waste generation? So in a recent decade, we will talk about ceramic industry, whatever we discussed very initially. So we know that day by day use of that ceramic material is means in a general use, like we are using for tiles, or for pavement, or like for any type of structure, we can use ceramic. So in recent trend, the ceramic industry has undergone profound technological changes of manufacturing process, as well as the characteristic of the final product, like porcelain, a ceramic coating, which has earned a growing role in the consumer market due to technical and aesthetic properties, such as water absorption for less than 0.5%, and high mechanical strength came along with those innovations. Now, this is the simple line, but here what is the very salient feature? Less water absorption and good strength. Whenever ceramic waste come in picture, so it is directly connected to concrete production. It is directly connected to structure, because in a previous lecture I told that concrete is the material which is widely used by mankind after the water, means it's in a second demand. Okay, and if you are at wherever right now you are sitting, in your office, in your classroom, in your lab, or in your home, so you can feel that how much you are connected with the civil concrete. Fine. So this is the second widely most used material, and whenever ceramic waste come in picture, so concrete automatically will come in picture, and there is a less water demand by using that ceramic waste, and strength is good. So because of that advantageous technological point, this waste is in demand to use. Fine. Then, if we'll talk about the porcelain is characterized by a dense microstructure consisting of crystalline phase, then malite and quartz in less amount minority, mostly majority immersed in a glassy phase. So we can say that these materials are like a very dense, having a very good microstructure compared to even whatever concrete we manufacture. Whatever concrete we manufacture, compared to that, ceramic is a very dense thing, having a very good microstructure. So there is a less that water permeability and everything. So this is a very good for any structure, because you are from whatever field you are having, but you feel that in a rainy season, in most of the home, or maybe not most of the, but in rainy season you feel that there is a some water is coming from roof. Okay, or means your wall having a problem of damp. Okay, so you just think whatever field we are having, right, whatever field we are having, but we are talking about our general thing by connecting with that waste and things. Okay, so that ceramic is a very good, like there isn't any problem of damp. Then if we are using that material in a proper way with a proper planning and proportion, then whatever that water coming from roof, that problem can be solved very easily. Okay, and ceramic waste is classified as non-hazardous industrial waste, means it will not affect mankind environment in that much drastic matter, right? Classification of ceramic waste by type and production process, will talk about that. Then ceramic waste having a red paste and white paste. Okay, so what is in a red paste? One fired and twice fired, means it is only one fired. So this is a brick, block, roof tiles, then porous stoneware tile. If we'll talk about a twice fired, then porous stoneware. And if we'll talk about white paste, so again there will be one fired and twice fired. But in white paste, you just read the word and understand that sanitary ware, white paste, porous stoneware tile, white paste, stoneware tile, white paste, China stoneware tile, generally white paste. Then if we'll talk about a twice fired, then porous stoneware tile. Means both the things are available in a red paste, white paste, in one fired, in twice fired, in ceramic waste. So this is the image. In that image, you can see the packaging of insulator at factory and waste filling outside factory. Okay. So from that waste, you can sense that this is the unusable product of that industry. They are just throwing after the after the manufacturing of their exit product. And here you can see that labor carrying ceramic waste for land disposal. This is the last option which we discussed in last lecture, that land filling should be last option, but nowadays people are choosing that as a first choice, land filling. So here you can see clearly in picture, there is an industry, the product is finalized in that packets. You can see the packets over here like tiles, but whatever the raw material like a waste, this is on a field and people are collecting for land filling. And here you can see the exit scenario. This is not like any picture. This is the real picture of any village or any nearby industry which is having a ceramic industry, and you just see the ceramic waste used for landfilling over here. Here also you can see same thing, ceramic waste piling on urban road, you can see. Fine. So people are just using in that. But what is the recent development in ceramic waste? This is reuse. Answer is written over here. Recent development in ceramic waste is reuse. So here you just see the picture. Utilization of ceramic waste in the manufacturing of ceramic tile. This is not directly manufactured tile from natural raw materials. These tiles are made from ceramic waste. Okay, whatever you are seeing in that picture. So there have been numerous attempts to utilize ceramic waste in the manufacture of wall and floor ceramic tiles in the last 2 decades. This was the scenario. The industrial waste are important part of them that we know. Cement kiln dust, CKD. That this is the this is the product which come during the cement production. So cement kiln dust as a great troublemaker waste was utilized in ceramic tile bodies to replace half the feldspar required for ceramic wall tile body with the double target of cost reduction and environment protection. So here whenever cement production in picture, so cement kiln dust which is having a very these particles are having a very micro dimensions, and if any person will inhale during breathing, so these cause the very hazardous problem to that person. Okay, so this is not a good thing whenever cement production is going on and person are dealing with that cement production and cement kiln dust is there. So this is not good for environment as well as for living, means as for human being. But that cement kiln dust, which is the problem for waste management, that dust is using in a ceramic tile. Fine, ceramic wall tile. So that waste is used in ceramic wall tile for production of a ceramic product. So we are doing waste management from cement industry. Okay, so you just think ceramic product production industry. Fine. Cement production industry. So cement production industry is waste like cement kiln dust, which is we are using in ceramic wall tile production. So we are getting two advantage. One industry is waste management, and another second industry is waste management. So from both industries waste we are using, and we are producing one object like ceramic wall tile. Okay, a lot of research work has been carried on the properties of red slurries produced as waste in the industrial production of aluminium from bauxite ores using the Bayer process. Red mud as pigment was used in the manufacture of unglazed stoneware tile by fast firing technique. Here you can see that utilization of ceramic waste, whatever ceramic production, tile production is there. So whatever waste is there, which we seen in pictures, so that waste is a grinded, and in a grinded or that they are using to manufacture clay brick, which is used for construction work. Now, utilization of ceramic waste in manufacturing of clay brick, whatever we seen in previous slide. So, recycling of different ceramic waste in the production of fired clay brick. Building brick means whatever brick we are using for construction, for home or residential official buildings, was widely investigated. During production, especially in the firing, transportation, and construction state, large amount of brick are broken and have to be dumped in landfill or used as a filling material. That we know. Even our home is going to construct and any site is going to construct, we are seeing that whatever product is coming for manufacturing, or sorry, for that building construction purpose, but there is a some type of waste will be there. So there is a clear waste from that brick industry also. Fine. On the other hand, ceramic tiles industry produce a lot of waste such as ceramic sludge, broken under quality tiles, and accumulated dust. Ceramic industry is there, so ceramic waste will be there. Why? Because this is the thing. If we will uh, if it will no, drop from certain height, so it will break, so that breakage and whatever, if any product is there, and if it is not that much furnished as per the application and as per the use of that structure, then this is already a waste. So such sludge, broken under quality tiles, and accumulated dust, these all are the waste come under ceramic, yeah, under the ceramic industry. Okay, these waste constitute a great pollution problem to the surrounding environment. Up to 50% ceramic sludge additive were mixed with foam ocean clay raw material in Upper Egypt for making building bricks. This is the scenario of Egypt, that they are using that material. Now, if we are using utilization of that ceramic waste, whatever come under dust, whatever broken pieces, broken material, then not that much furnished product, like maybe it will be a tiles or any object. Okay, so from that waste, people are also making vitrified clay pipe for some purpose. Fine. So now utilization of ceramic waste in a vitrified clay pipes we are talking. Then vitrified clay sewer pipes are used for sanitary drainage due to their corrosion and abrasion resistance. They are manufactured by mixing clay, groge, and feldspar as fluxing agent. Waste bypass cement dust in different percentage ranging from 2 to 10% to a standard mix for sewer pipe manufacture is substitute for expensive feldspar. Okay, so if whatever we are manufacturing from expensive feldspar, so yes, we can say that from ceramic waste we can manufacture vitrified clay pipe, right? Then the main, these all are the things that which we can use, but whenever ceramic waste come in picture, so it is directly connected to concrete, cement. Okay, so here you can see utilization of ceramic waste in the manufacturing of blended cement. Okay, so we know that there is a ordinary Portland cement, then Pozzolana Portland cement, OPC, PPC, we know because we are using in construction. But if we are talking about the cement, then by using that material, we can use cement also. Researchers also studied the utilization of both fire-dried and white ceramic waste and their combination as a substitute of raw material in the manufacture of clinker itself. The results showed that they were technically viable and have higher reactivity and burnability than a conventional mix, providing that the particle size of waste used in lower than 90 micrometer. 90 micrometer means we can use as a cement. The potential utilization of colored glass cullet in various cementitious products was found to be very encouraging, especially for decorative and architectural applications in many places. Find that blended cement. If we are not going to use for some construction purpose, some structural purpose, so for decorative purpose, we can use that cement which we manufacture from the ceramic waste. Now, this is the again another thing, you can see that some demolition is there, means any building or any structure is demolished. Okay, so that demolished part, okay, in a some like this is having some 10 mm 20 mm dimension, near around 10 mm and 20 mm dimension. If that dimension is not there, then whatever construction demolition waste is there, this is also part of ceramic waste only. Okay, so by whatever waste is there, we have to make it available in a 10 mm around and 20 mm around, so we can use in concrete. So utilization of ceramic waste, whatever come under construction and demolition. Okay, so this is we can use in a manufacturing of concrete. Here you can see that disc insulators waste, from that what we generated waste ceramic aggregate, that from that disc insulators we converted it in aggregate, and that aggregate are called as waste ceramic aggregate that we can use for concrete manufacturing in a place of coarse aggregate, that aggregate size having a 10 mm and 20 mm. Now you can see utilization of ceramic waste in the manufacturing of concrete. So here you can see that construction industry is a massive consumer of natural resources and a huge waste producer as well. Because in a previous lecture, I didn't remember I mentioned or not, but here I want to again that quote, that only that our civil industry, if I'll talk about the civil construction industry, this is responsible for 5 to 15 or 18% responsible for CO2 emission in environment, for like cement production, for concrete production, by using steel in construction. So there are so many factors. So here we can quote that construction industry is a massive consumer of natural resources and a huge waste producer as well. What are the major problems? Environmental damage, pollution to our Mother Earth. Therefore, utilizing the recycled aggregate may be one of the significant effort in achieving sustainable construction, right? So here we can say that many countries have now introduced various measures in it reducing the use of primary aggregate and increasing reuse and recycling, where it is technically, economically, or environmentally acceptable. For example, UK government has introduced landfill and future extraction taxes to improve economic viability and support to relevant research and development work for recycled aggregate. If I will talk about some government agencies, then Department of Science and Technology, then Technical Scientific Department, then CSIR. So there are so many central government, state government bodies, they are supporting such type of collaborative work which is reducing waste generation, which are sustainable. So government are supporting such projects, such collaborative work by doing funding. So here, what is the current method for concrete aggregate? We know that ceramic waste is there in a powder form, like in a very hard form. We are converting in a 10 mm, 20 mm. But what is the exact method for concrete aggregate? So here you can see that stripping will be there from any quarry. Then blasting will be there in quarry only. Then stock filling is there in quarry. Sorting process means whatever material, whatever stripping, blasting, and stock filling they did. After that, they have to do sorting. So after that sorting, maybe they will directly go for waste like wood, etc. Fine, because in that process it is not like that. Only whatever product you want for ceramic will be available. Okay, it may be available in a steel, means some steel pieces will be there, some wooden pieces will be there, some paper type of material will be there. Okay, so after stripping, blasting, stock filling, and sorting process, there is a waste like wood will be there. After that, waste like wood they will segregate. Then after, what will be the step? Primary crushing will be there, then secondary crushing will be there. They will use the shaper. By shaper, they will extract the product whatever they did after, whatever they achieve after primary and secondary crushing. And after the using the shaper, they will go for screening. And when they will go for screening, they will get fine aggregate from 7, 10, 20, and 75 mm. Okay. During primary crushing, also that aggregate we can collect. Okay. But if we need a well graded, well dimensioned aggregate, then we have to follow the path. After primary crushing, we have to go for secondary crushing, then shaper. By using shaper, extraction will be there, and from that extraction, screening will be there, and from that screening we will get 7, 10, 20, and 75 mm aggregate. Okay, here water supply will be there for screening. Now whatever construction waste will be there, so what we will do, we will go for stock filling. We means the person who is dealing with that waste management, or by collecting that waste they are just giving aggregate to like construction field. Okay, so construction waste will be there, they will go for the stock filling. After that, as per previous, sorting process will be there, excavation will be there. Okay, excavation. So after that combined process, maybe waste include wood, paper, steel, so many things will be there. And from that waste, what they will do landfilling. But here, after excavation, they will go for primary crushing, then magnetic separator. Why? To collect steel scrap, right? Then they will go for secondary crushing, and they will do by manually removing. After the manually removing, whatever waste will be there, they can collect and they will do landfill. During sorting process, excavation, such a waste will be collected and directly go for landfill. If we will follow the path of primary crushing, magnetic separator, secondary crushing, then also during manual removing, we will collect the waste and that will be go in landfilling. After manual removing, whatever material we collected, that will be go under screening, and for that water supply will be there. And after that, we will get final aggregate having a 7, 10, 20 mm and 75 mm in size. And that these all size are used in concrete manufacturing. Fine. So the effect of using ceramic waste like roof tile, block, brick, electrical insulators as aggregate or supplementary cementitious material in conventional vibrated concrete and mortar was reported in similar studies. Means researchers are doing work in that field by using ceramic waste. Ceramic waste could be used as partial replacement of natural coarse aggregate. Okay, we can use to prepare blended cement, but again this is a partial replacement. Okay, the replacement less than 50% is a partial, and more than 50 is like full replacement or maximum or optimum replacement. The ceramic waste aggregate should be pre-saturated by water to offset its high absorption. Okay, it should be pre-saturated. Why? Because it is already a product. Okay, so that product definitely absorb water. Using a high content of ceramic waste, a fine aggregate had a negative impact on the workability of fresh concrete. Means we can say that fresh concrete having a good workability, but the concrete we manufacture with the ceramic waste having not that much good workability because it's already having a high water absorption. Okay, and high water absorption means for that concrete we required high water, so workability strength will be affect. But for that also our researchers are working and they are giving good solution that we will talk over here. Here we can see the physical properties of aggregate, what we collected from that aggregate from ceramic waste industry. We use the ceramic industry waste, we collected aggregate from that. So this is the natural aggregate. You just see the property, natural aggregates property, and this is the recycled ceramic waste aggregate. So you just see specific gravity. This is like a near around, natural aggregate having a more, recycled having a little less. Water absorption, natural aggregate 0.75, recycled 0.60. Crushing value 17.15, here 24.66. Impact value 14.46, in recycled that will be 23.23%. Abrasion value that will be natural 8.5, and recycled that will be 23.92%, and finest modulus will be 9.91 and recycle 9.23. So we can say that so many advantageous properties of that recycled ceramic waste aggregate compared to natural aggregate. So we can use that aggregate in place of natural aggregate. We can save natural resources and natural environment also. Fine. If we talk about the concrete mix proportion, so generally whenever 20 mm 10 mm aggregate we have to use, we know that generally we are using a structure having a M20 grade and we are going some high rise building or some important structure, so we are going for M30 grade of concrete. Maybe there will be not a cup of everyone's tea, but as a technical person, as we all are connected with the civil too and concrete too, because we are using concrete as a second widely most material. Okay, so these should be in our knowledge that if M20 and M30 grade of concrete we are going to prepare, then for cement, coarse aggregate, fine aggregate, water demand, water cement ratio, this is a mention over here only for our knowledge. So by using that properties, by using that materials property, we will find some strength like shear strength, because concrete is very good in compression. So we have to focus on another strength perspective. So if we'll talk about the shear strength, so here you can see that natural aggregate concrete NAC, this is a M20 grade, and ceramic waste aggregate concrete. So at 7 days the strength is 4.02, and whenever we are using waste, so this is 3.32. At 28 days natural aggregate will be there, so 4.33 megapascal strength will be there, and whenever we are using waste, so this is 3.924. Okay, not that much vast difference. Okay, so whenever strength is not that much important, structural part is not that much important, so we can use that concrete very easily. Here you can see M30 grade with the natural aggregate concrete. At 7 days, 4.67 megapascal strength. At 20 days, 5.23. And whenever waste is there, so here you can see 4.26 and 5.13. So again, there is not big difference. So in place of natural aggregate, we can use ceramic waste aggregate. In flexural strength, if we will not go with the that weight load, first break, ultimate load, and we will directly discuss about the strength. So you can see for natural aggregate, this is a 26 megapascal around. For ceramic waste, it will be 24 megapascal around. In 30 for natural aggregate, it will be like 26 around, and for ceramic waste, it will be nearby 25%. And load first break, this will be 5.4 over here. In ultimate, that will be 14.72. Load first grade ultimate load, this is showing that whenever your structure, you are sitting in a any building and that building is going to collapse, so if you made that concrete from natural aggregate concrete, then that will be having a first break at 5.4 megapascal that is stress. Okay, 5.4 megapascal stress will be there, so you can observe the crack. And at 14.72 megapascal, sorry, 14.72 ton. Okay, this is the value in a ton. So if 14.72 ton will be there on that structure concrete, then only it will collapse. So it will giving you some time to rescue yourself. Okay, so here that data only reveal, this data only try to reveal that compared to natural aggregate concrete, that ceramic waste aggregate concrete is little bit having a less value, but not having that much vast difference. So whenever strength is not that much important and not required that much, so this is a acceptable concrete. Fine. So what is the key benefit of such waste? We are talking about tiles, brick, and waste and aggregates. So what is the key benefit of that waste? So we know that waste management, any ceramic industry is there, whatever dust is there, broken material, unfurnished material. So by using all these material, we are going to make pipes, we are going to make some blended cement, we are going to make some brick, some pipes, then concrete. So waste management concept is there. Cost effective and feasible is there. But we are talking about sustainability. So from that waste, we can make most of the civil engineering field related products. Okay, like brick, pipe, aggregate, concrete. Okay, so we can say that there is a sustainability of that ceramic waste in our world. If we'll talk about the durability concept, so whatever product you have seen that is related to our civil engineering field, okay, so whenever civil engineering field will be there, construction will be there, some aggregate, some material is there, so there should be some concept that that material resist against aggressive environment or not. So yes, that product can resist against environment, aggressive environment. Like if we are constructing structure in marine environment as a seesaw, okay, or some acid rain is there, there is a change in environment. So yes, the structure which we make using ceramic waste, so that can resist against aggressive environment. If we talk about cost effectiveness, fine. If we talk about cost effectiveness, so yes, we are using waste, we are simply using waste. Okay, so natural aggregate we are saving, we are just collecting waste and we are making our product from there. So cost saving is around 7 to 12%. Okay, as per the researchers' data. If we are talking about feasibility, so feasibility, what it states, the cost, technical operation, investigation, it's a value, it's a legal analysis, fine, it's a business, accounting. So as per all aspect, that product is coming in a positive way, that in all aspect it's suitable. So this is a feasible. And if we talk about the summary, then from that lecture, we have to just summarize that from the previous expose, it is clear that ceramic waste can be classified as non-hazardous industrial waste. Ceramic waste include electrical, porcelain, insulator residue, white ceramic, sanitary porcelain ware, roof tiles, cement kiln dust, fired clay brick waste, glass waste, ceramic sludge, ceramic broken under quality tiles, and the accumulated ceramic dust. Ceramic waste were generally suitable for use in construction industries such as ceramic wall and floor tiles, vitrified severe pipes, building brick, blend and cement, or as an aggregate for concrete manufacturing mainly. So in that ceramic waste, whatever I just want to convey to you, that key point I included in a presentation I discussed, and for that references are over here. These are the references from by going through that. I prepared some key points for that waste, and for regarding that particular topic, you have any query, question, you want to go for detailed discussion, you need some scheme, some collaborative type of work in that field, you can email me. My contact number is there, my email ID is there. And for that particular session, I just want to conclude with the line, if we are making progress, we are doing good thing, we are surrounded by so many things which is responsible for waste generation. So as a technical background person, as an academic industry person, we should be aware about the waste management concept of that and how we can utilize it so we can make clean our environment. Thank you so much. Now you have any question, so you can ask me, because today organizer told me that ma'am we have to wind up lecture till 3:30. So remaining question answer we can take, and after that we can take another lecture of a yoga and like something. Okay. So now any question is there, you can ask.
Uh, Thank you, madam.
Yes.
Thank you, ma'am, for a wonderful session. Um, we have a couple of questions for you, ma'am.
Yes.
Are the constraints like preparation, transportation, cost, storage, and handling of ceramic waste bottlenecks for recovery with cost effectiveness? Is
Sir,
it
cost effect, yes, sir. Here I will give that question's answer in a 2-3 ways. First matter, there's this is a waste. Okay, this ceramic waste, there isn't any specific storage or anything required. Okay, people are dumping that waste anywhere. Okay, so just that industry can provide us that waste on our open field. No specific storage is required. This is the first matter. Second matter, if we talk about the waste recovery, if the recovery of that waste, then that will be till 24% around recovery rate. Okay, and we will talk about the cost effectiveness of that material. So by utilizing that material, I will simply give example. If my concrete production, for one cubic meter concrete production having a 5,000 rupees 5,000 rupees rate. Okay, so if I will use that material, so I can reduce cost till 15 to 21 percentage, 15 to 21 percentage, right? This is the simple basic.
Thank you, madam. Uh, as a corollary to this question itself, it's been asked by Mr. Gurulingam, is it not adding concerns to the dust pollution? Instead, land filling may be more effective. Actually, this question is a continuation of that previous question only.
Yes, sir. Sir, ceramic waste will be there, so dust will automatically come in picture, because many of us experience that whenever any construction is going on and whenever tiles are coming, so some dust are there. So dust is also a pinpoint in that. Land filling is a good option. Land is also, sir, there is a fertility of that land will what we can say that will affect if we'll go for land filling by using ceramic waste. So fertility will be effect, but that the ceramic waste will come in picture, so dust part will come in picture. But by using that dust, we are making blended cement. Means whatever cement right now we have, by using that dust, we are using that dust as a what we can say that another ingredient to manufacture another cement. So best way is land filling, but no, sir. There are so many things like blended cement, cement manufacturing, then pipe making. Such things are there by using that waste dust.
Thank you, ma'am.
Yes,
Uh,
sir.
the next question comes from one more participant.
Yes, sir.
He's asking, like, how can the concrete mixture comes under the ceramic recycling process? The quantities which we are using to mix the cement are of different on both the sides. Can you explain the clear picture on how these happens like a process? Thank you, ma'am.
Sir, please, you repeat question. There is a little bit confusion.
Yes, yes, madam. I
Yes,
again repeat it, madam.
yes.
How can the concrete mixture
Mhm.
come under the ceramic recycling process?
Okay.
The quantity, next line, the quantities which we are using to mix the
Mhm.
cement are different on both ones. Um, can you explain the clear picture on how this happens like a process? Actually, I think he's asking the concrete mixture how it
Process.
comes under the recycling process. I think that's what I could make it out.
Yes. I am also sensing such type of thing. So I am giving an answer as per that. If that participant will not satisfy, then please ask me to email and WhatsApp. But as per the question I understood, I am giving the answer. Suppose we have that ceramic waste. Okay, that ceramic waste in a demolition type, or maybe like from direct industry. This is in a piece, some pieces. Okay, that waste. Just we have to collect that waste. Okay, we have to go with a process that we have to make in a 10 mm and 20 mm size. Why? Because we are going for concrete manufacturing and we are using that waste as an aggregate. Okay, so we have to collect that waste. We have to make in a 10 mm and 20 mm aggregate size. And whatever our ideal concrete mixing method, like at first we have to collect cement, sand, fine aggregate, coarse aggregate. By calculation of concrete mix design, we have to add water. That waste material is there as an aggregate. So we have to use some super plasticizer, some chemical, some admixture, and then we have to rotate in a concrete mixture pan. So this is the simple method. By using that waste, we can produce concrete as per the normal concrete. But what will be the difference? Water demand will be different, workability will affect. So we have to use admixture, we have to use super plasticizer and chemicals. Right. So this is the clear picture about the concrete production using that waste, and that will come in a aggregate type. If you are using that waste in a powder form, then again your concrete mix design will differ. Why? Because in a powder form means you are using it with cement. So your fine aggregate sand will be there, your natural aggregate, coarse aggregate will be there, and with the cement you are using partial replacement, that powder. Okay, so concrete mixing method is not that much differ from our traditional concrete mixing method. But though you are not satisfied with the exactly answer, you can email me clearly. I will give you the proper, or we can communicate more in that. That what you want exactly. Maybe it is not addressed right now. Yes, sir.
Thank you, ma'am. Uh, this one question is, what are the occupational hazards occurring from scavenging ceramic waste?
Sir, occupationals, we can say that because of that in a ceramic waste, only dust is a pinpoint, because ceramic waste will be there, so some dust will be there, and if any person will inhale, then there will be the asthma or any heart issues. So that type of health issues will be there. As a occupational, we are talking about that.
And the final question for the day: when it is not throwing any, hazardous issues,
Yes.
why at all to think of processing ceramic waste?
Yes, this is a very good question, because very initially I just told to participants that I am reading that line perfectly. Why? Because I am giving you the history scenario that India's economies also depend on that very nicely. Why? Because Earth is having a specific area, okay, and construction progress is going on. So construction in a tremendous way it is going on. So ceramic industry have to play a vital role in that. If ceramic industry is involved in construction process, so there is a huge amount of waste production is there, okay. That waste is not that much hazardous, but if we are throwing it in a landfilling or anything, so at certain level fertility of that land will be affected. Okay, so better we will use that waste for another material, another purpose, another work. So there will be zero waste from ceramic industries. So because of huge amount of production of that ceramic, we are a ceramic product. We are using the waste of from ceramic industry in a different way.
Okay,
Yes,
ma'am.
sir.
I think that's all for the questions, it seems, from the participants. And I again thank you, ma'am, for again presenting a very, very interactive session. Again, as being a mechanical engineer, I think we were able to understand the concepts behind it. You put that presentation in a very easy to understand manner, ma'am. Ma'am,
Yes,
you are
sir.
the star speaker of this FDP, I think.
Oh, is it like that? Thank you. Actually, I am really I am feeling so sorry for the participants that we are not interacting. But the thing is that I want to tell you so many things, but time is the limit. Okay. So I am just explaining from myself, and you all are welcome, and you all are open to ask me any question from my phone number and from my email ID. So you can contact me, and you can interact through that way lifelong. Okay.
Okay, ma'am. Thank you again
Okay. Thank you, sir.
being a part of our faculty development program team, ma'am. It's been a wonderful having you here and interacting again with you, ma'am. Thank you
Thank you,
very
sir.
much. Thank you
Thank
very
you
much.
so much. Thank you, one and all. Okay, thank
On
you.
behalf of Dr. M.G.R. Educational Research Institute, Department of Mechanical Engineering, we once again express our heartfelt gratitude, ma'am. Thank you
Thank
very
you,
much.
sir. Thank you
Thank you.
so much. Thank you.